Welcome to this explainer. You know, it's actually wild how a seemingly brilliant AI multi-agent workflow can turn into a catastrophic regulatory failure practically overnight. Today, we're diving into the absolute strict engineering requirements needed to take a LangGraph workflow from a local developer environment and transform it into a hardened, production-grade system, one that can actually survive a rigorous compliance audit.
Picture this. You're the lead engineer at Argus Compliance Group. They're a massive $190 million compliance tech vendor, right? And you just shipped version 0.7 of your multi-agent LangGraph build. Reviewers absolutely loved it. It seemed to work flawlessly. But then, a FinCEN examiner sits down for a routine exam and drops this chilling request on you. Show me the state at the moment the confidence dipped below 0.7 on packet 1407, and your stomach completely drops, because you realize in that exact moment your system has literally no way to reconstruct it. The agent ran, the packet was delivered, but that intermediate state, it's just gone.
So why was Argus in such hot water? Well, it all boils down to a massive shift in the rules. The April 7, 2026 FinCEN Notice of Proposed Rulemaking completely changes the game. We're moving away from process-based compliance, which is basically just asking, hey, did you follow the steps, to effectiveness-based compliance. Regulators now demand that you prove your program actually detects financial crime. And here's the kicker. The only way to prove effectiveness is through exact state reproducibility. If you can't replay the exact state path at the moment an AI agent made a confidence decision, you simply cannot defend your program.
Here is the roadmap for this explainer. First, the Argus compliance failure. Second, the multi-agent orchestrator pattern. Third, the 5-state invariants. Fourth, wiring the LangGraph workflow. And finally, production pitfalls to avoid.
Starting things off with Section 1, the Argus compliance failure, or, as I like to call it, a $190 million demo.
So what exactly went wrong for them? Well, their system was missing two absolute must-haves: proper state saving, which is a checkpointer, and a human-in-the-loop escape valve, specifically an interrupt_before route. Without these safeguards, the agent just silently progressed through the workflow, constantly overwriting and destroying its own intermediate state along the way. Argus didn't ship a product at all, really. They just shipped a very expensive demo.
Moving right along to Section 2, the multi-agent orchestrator pattern, which has become the 2026 standard.
Let's break down how an anti-money laundering, or AML, pipeline actually flows. It's built on an Orchestrator-Workers pattern. Think of it like a highly coordinated factory. You have Agent A, our sanctions and SAR scanner, and Agent B, our beneficial ownership cartographer mapping out corporate structures. These are your specialized workers. Then Agent C steps in as the orchestrator, taking all those specialized findings and composing the final packet. It's a beautiful architecture, right? But it only survives the real world if the shared state flowing between these agents obeys some very strict rules. That brings us perfectly to Section 3, the 5-state invariants. This is how we go from a fragile demo to a bulletproof production system. Okay, here are the big 5. We're going to break these down one by one, but let me be super clear right up front. Skipping even one of these 5 structural rules is the exact difference between passing and failing an OFAC or FinCEN exam. These aren't just nice-to-have suggestions. They're the absolute bedrock of a defensible system. First up is invariant 1, the append-only audit trail. This is derived from Greg Young's event sourcing concepts, and the rule is simple but critical. Agents never, ever mutate another agent's output. They only append. So if Agent C overwrites Agent A's sanctions findings just to make the final packet look a little cleaner, your audit trail vanishes instantly. When the examiner asks what Agent A found at a specific timestamp, well, the question becomes entirely unanswerable. Next is invariant 2, typed schema on every edge. Every single node must only read and write explicitly declared fields on a typed-dict or Pydantic v2 state class. If you use untyped state, like a generic Python dictionary that just accidentally grows new fields on the fly, that's exactly how a crucial sanctions hit just silently disappears from a final packet, all because a downstream agent inadvertently overwrote the key. All right, invariant 3 is state machine completeness. Grounded in David Harrell's 1987 work on state charts, this means every node must have an outbound edge for every possible value it can generate. Imagine your routing logic can return high, needs review, or escalate. But let's say your conditional edges only map paths for high and needs review. So what happens to escalate? It hits a dead end. That implicit fall-through means a high-risk packet quietly closes out without human eyes ever seeing it. That is an absolute compliance nightmare.
Moving on to invariant 4, the human in the loop, or HITL escape valve. You know, silent confidence is easily the most dangerous failure mode in AI systems. Every confidence-bearing node has to compare its score against a strictly calibrated threshold. If the agent's confidence drops below that mark, it absolutely must trigger an explicit interrupt route to human review. You can't just let a low-confidence packet complete on its own. A human compliance officer has to step in and clear it.
And lastly, invariant 5, checkpoint determinism. This draws on Leslie Lamport's famous 1978 paper on ordering events. It mandates that given the exact same input and the exact same checkpoint ID, replaying the graph must produce the exact same state path every single time. This exact reproducibility is completely non-negotiable. It's what the April 2026 FinCEN effectiveness standard demands to prove your program isn't just hallucinating, but is actually detecting financial crime systematically.
Okay, let's look at section 4, wiring the LangGraph workflow. It's actually amazing how these abstract compliance concepts map one-to-one with explicit LangGraph primitives in version 1.2.0. Your typed schema becomes an AML state class using typedict or pydantic. State machine completeness, that's enforced by using add conditional edges and exhaustively mapping keys for every possible outcome. The HITL escape valve is literally just the interrupt before argument on your graph compile, and checkpoint determinism is achieved by wiring an AsyncPostgresSaver directly to your production database. In this world, the code literally is the compliance. Which leads us to our final section, number 5, production pitfalls to avoid. Okay, before you ship your setup, you have got to watch out for this massive trap, your choice of checkpointer. MemorySaver is super convenient when you're just testing locally. But the moment you copy-paste that into production, you violate invariant 5. Why? Because the very first time a server worker restarts, the entire state is wiped clean, gone. Your exam defense is instantly destroyed. You absolutely must use a robust solution like AsyncPostgresSaver in production so you can persist that state for examiner replay. The second huge pitfall is implicit fall-through. We touched on this with invariant 3, but it is so important it bears repeating. Always explicitly map your destinations in your add_conditional edges function. If your router has a path for escalation, that path has to be explicitly mapped to a human review node. Leaving it unmapped allows high-risk packets to just silently fall into the void. And let me tell you, that's a surefire way to meet a FinCEN examiner in a very uncomfortable setting. So that leaves us with a pretty heavy question. Take a hard look at your own workflows. Are you strictly enforcing these 5 invariants? If an examiner asks for the exact state of a packet from 6 months ago, can you actually reconstruct it? Ask yourself, is your workflow truly ready for the regulatory spotlight? Or have you just shipped a very expensive demo?